Welcome to a lesson with Dr. Powell. Oftentimes, substitution can happen with trigonometric functions. So here's an example. What if we have the cotangent raised to the fifth power of x multiplied by the cosecant of x dx? What would we do? Well, we can think about some identities here and also some derivatives. You notice how you see a cosecant times a cotangent? There's also that times more cotangents, but cosecant x cotangent x is a derivative. And it's nice to find derivatives when we're doing substitution, because that might be like the derivative of what our choice of u might be. Well, what could a choice of u be? Well, that would mean that u would have to be, you could make u be equal to negative cosecant x, because that has its derivative that right away. So that's a possibility. Or you could say u is this, and then that would be its derivative. Either way, why don't we just pick, but why don't we actually pick u to be plus cosecant of x this time around, and then just say its derivative is that. Okay, let's see where that takes us, and then we'll kind of, work from there. So we can replace our dx with du over the derivative of u, which is that negative cosecant x cotangent x. And what's that going to do? Well, that's going to cancel out the that's a cosecant and cosecant, and it's going to cancel this out with one of the powers over there. And so we end up getting negative integral cosecant to the fourth of x du. Notice we have an x and a du. We need to write this in terms of u. Now u is oh, that's a cotangent. Sorry. Haha. That was a cotangent right there. Excuse me. Cross out one of the powers, so it's 4 cotangent to the fourth of x. We need to write this in terms of u, which is cosecant. How do you write cotangent in terms of cosecant? We appeal to identities. Let's look at Pythagorean identities. Notice, so if we take cosine of x and we square that, plus sine squared is equal to 1, what can we do to this to get out a cotangent and a cosecant? If we just divide everything by, let's see, by sine squared, we'd end up getting a cotangent over here, plus a 1 is equal to cosecant squared. So this is an identity here. Notice that cotangent, we can solve for it as cosecant squared minus 1. So that would mean, but we have it to the fourth power, which means we simply could have cosecant squared minus 1, and that's squared, because that would be cotangent squared and squared. So that would be fine. And this would be great, because then we could change this cosecant squared to a u squared minus 1 squared du. And then that would be the integral of u to the fourth minus 2u squared plus 1 du. And then finishing it off, I'll just finish it up here. We would end up having, so u to the fifth over 5 minus 2/3 u cubed plus u plus c. And then just replace u with what it is. U is cosecant x. So we end up getting cosecant x to the fifth over 5 minus 2/3 cosecant x to the third plus cosecant x plus c. And that would be the final result of the antiderivative. Thanks for watching.